All right, so welcome back. Welcome back to this video. So in the last video, we have built a text summarizer, right? In TensorFlow, we have developed a text summarizer. In this video, also, we are going to build a similar project. At least the architectures are going to be similar. We are going to use the same transformer architecture to actually build a machine learning neural machine learning translator, as I have promised in the last video. So we are going to build a basic we're going to train a basic neural machine translation model. So it is going to be very good. So let's start. Let me wait a minute. Okay, so let's start. So as you first, let me introduce the problem to you. So we're actually in this video, we're actually going to build a English to Spanish translator. So we'll train a model which can understand the relation between English and Spanish. So whenever you provide a input sentence on English, we're going to translate the same sentence into Spanish, right? So that is a problem that you're going to solve. We are going to train a language model, right? So language model is nothing but a model. Even Chat GPT is an example. So we're going to train a model like that, not that powerful, of course, as we have very limited computational power. So we'll be trying to build a neural machine learning translator, right? So first we are going to import the necessary libraries. So pathlib to actually like interact with many files, right? So we'll be downloading one file from one link, right? So to actually interact with this file, we use pathlib, and we use random to actually generate or get random sentences. So we're going to have test sentence a list, and we're going to use this random to actually get random strings, and then we are going to import string. We are going to import RE to actually perform some string operations. We are going to import NumPy, TensorFlow, Keras, layers, and text vectorizer function from tf.keras.layers. So those are the main imports, I believe. And then in the next next code cell, we'll actually download the data set. So we are going to download this data set from this link, right? So this link will we'll download the data set. Again, the link of this code will be in the description. So in the description, I'll just paste I think a GitHub link in which we'll just you can find the code and also download the code. Right, so we'll run that. I've already previously run this, because in the last video also I didn't run it before you because it takes a lot of time. And then if I am recording at the same time of training, that might slow my computer down. So that is why I trained this just now. So after it finished training, I just came here. As you can see, the tick marks here represent let the model is trained. So it is this is the model. So first we are going to get the data set, right? Import the libraries, get the data set, and then we're going to perform this text processing. So we're going to process this text. So we're going to open this file, and then we're going to read it, split it. So we're just going to open this file, txt file, and then we're going to read it into a string or a list, and then we're going to split it. We're going to add start and end tokens, right? And then we're going to actually get a text pairs. So we're going to get English Spanish pairs. So for each English sentence, we're going to have the same corresponding Spanish translation, and then we're going to have these as pairs. So this, as you can see here, you can see the format of these pairs, how they're actually how they are. So we're going to have the first the English sentence and then the Spanish sentence. So yeah, right. And then we are going to here we are going to do some more just learning, just seeing what the data is. So how many pairs are there, how many training pairs and validation pairs. So you can see here we have 83,000 training pairs. So that's good, not bad. So we're going to have validation and test pairs also. And then we're going to replace some symbols that we don't need. And then we're going to we're going to use some rejects to actually remove these words and to actually format this. So we're going to actually also do lowercase, right? And then we will delete this and do some text processing. In the last video also, last product also we have did this pre-processing, and then we're going to do text vectorization, right? We're going to convert this text into just numbers, and then after that we are going to have word embeddings. We are not replacing word embeddings with this text vectorization. As I've already stated in one of the last video, embedding is better than text vectorization because embedding can actually track the features, and similar words will have similar embeddings, of course. So that's why we'll have embeddings again in the model. So before that, we're actually going to perform text vectorization, right? And then after that, we'll form the data set. We'll do the vectorization for both English and Spanish sentences. Sorry. Then we are going to get the TensorFlow data set so we can actually train the model. We're going to shuffle them just like we did, right? And then we'll just call this function. We have made this function called make data set, in which we'll just we'll just zip this space. We're going to extract this space, and then all right, uh, we are going to get this English pair separately and Spanish pair separately, right? Spanish text separately, and then we're going to form the data set. We're going to form batches, because batch training is definitely better rather than normal training, right? And then we're going to call this function on both the training and validation data. So we're going to have input and output sentences. Here up to now we're just like pre-process the data. We are just make sure the data is good. We have performed some string processing, right? We have created a TensorFlow data set that's such that we actually train the model, as we are building the architecture in TensorFlow also. So we start our wait a minute. So we'll start our model, right? So we'll start building the model. So this is how the model looks like. So we are going to directly build the transformer encoder. As you can see here, so these are going to be inputs: embedding dimension, dense dimension, number of heads. So we're going to first initialize this variable so such that we could use them in the following functions. And then we're going to have here the good thing is TensorFlow has already uh, had this pre-written multi-head attention function. So you don't have to write the old like multi-head attention. So multi-head attention, right? In the last two videos, we have wrote this multi-head attention function by ourselves. But the advantage of using TensorFlow is there is pre-written the libraries such that you can use them. You can just call them. So we have pre-written library of multi-head attention. So we'll just create an object of this class, and then we'll also create an object for the sequential class to actually build some dense layers, right? And then we are also going to like create objects of layer normalization classes, two normalization layers, and then we're going to create the call function in which we're going to create the padding mask. We're going to get the padding mask, and then we're going to calculate the attention output by we'll just pass these attention values with the inputs. So as I have told you, when we are performing normal attention, the query key and the value vectors will be just inputs, right? So this might confuse you for the first time. So all three will be inputs. You might say that we can only have one parameter, but that's for making students understand, or no. I think that is the reason why they put like three separate parameters: inputs, right? So all are going to be inputs, and then we're going to have attention mask also. We're going to add a mask while we're calling them, and then we're going to perform layer normalization, add a normalization. We're going to have go through a neural network, feed forward neural network, and then we'll have another normalization layer. So that is this function transformer encoder. It's actually pretty simple because we have all this pre-written code. Only one function, of course, multi-head attention. It's already pre-written by TensorFlow, so it's a so we can just use that pre-written function, and then we'll create the call function, right? Which is I've already discussed that. I think this is just for getting the dimensionalities, right? Yes, just for getting the dimensionalities, and then we'll have this positional embedding class in which we'll just create layers embeddings, right? So we'll just create embeddings, and then we are going to we are going to tokenize this embedding. We're going to create embeddings for these tokens. So now English sentences and Spanish sentences are just going to be tokens, are just going to be numbers, and then we're going to have embeddings. So we're going to create embeddings such that more information of these words are actually tracked by the model, and like it will be useful for the model. So that is what we'll be doing in this class. And then will be the decoder, right? So will be the decoder. Again, here also we're using a multi-head addition, because we don't have to use multi-head cross addition, because like both are same, except the input values are going to change, QKV values are going to change, except that the function is going to be the same. So we don't have to have another separate function called multi-head cross addition. So yeah, we'll be doing the same thing. We'll have some parameters, all these parameters that we're going to use here, and then we are going to build the attention one and attention two, which are going to be the same objects, and then also going to get the dense feed forward neural network layer, and then also we're going to get the objects of bunch of layer normalization layers, and then the main call function will create masks. We'll create the attention values here. Yeah, so as you can see here, attention value will have inputs, because this is just multi-head attention, not cross attention. But when you look at attention output 2, so the attention 2, where the inputs are going to be output 1, encoder inputs and encoder outputs and encoder outputs. So what we are going to do is, again, so the output of this attention output 1, attention 1, the output of this attention 1 will be attended to all of these sequences of the encoder outputs. So again, I'm going to remind you that these encoder outputs are not the inputs of the encoder. These are the outputs of the encoder. So remember that they are not just words. So we are not just going to have some like dense layers going on through some input embeddings, but these are going to be the the outputs of the embedding or encoder, right? And then also we're going to add the padding mask, to actually not give importance to padding so much. And then we are going to have the layer normalization 2, second layer normalization layer. Yeah, and then we are going to add and normalize. So right, we are going to add and normalize. So just we are going to have residual connections, and then we're going to have this final dense layer of this decoder, right? So we are going to build another function to actually get the attention mask. Right? So to actually get the encoder mask, you will have this function again. You can just read everything line by line. So yeah, and then finally we can create our model. We can create just combine all of our model. So we'll have this input layer. We'll have positional embedding after that. So after getting the input, we'll actually perform the positional embedding, and then we're going to pass that through a transform encoder, right? And then we are going to pass that to a. So this is going to be one separate part. So this is one separate part up to here. It's a separate part. We'll have the input, and input is going to propagate. And now here we're going to have decoder inputs, right? Decoder inputs being the Spanish sentences. So we'll pass the Spanish sentences to this decoder, because we want to predict as Spanish sentences. So we're going to have separate input, decoder inputs, and then we're going to have positional encoding and transformer decoder and dropout, and finally the dense layer. Right, as you can see here, this encoder outputs. So yeah, I think they have used it here. Yeah, transformer decoder, as you can see here, the encoder sequence outputs have actually been used here. So yeah, so yeah, you can see the connection here, how how both of these inputs are actually propagating throughout these layers. So you got that, right? And then we're going to have this final dense layer, and the number of neurons at the final layer is going to be the vocab size being the number of Spanish words that we know that are in the training set. So number of Spanish words that are in the training set is going to be the vocab size. So over all of these words of Spanish words we know, we are going to pick a word. So when at every situation, let's say we are going to predict a translation from 1 to 1. So when given an output, we are going to pick a word from all of the words that we know. So that is actually what is going to happen here. So that is why we're going to have dense layer with softmax activation function to actually pick a word. As you can see here, we'll have two inputs. So decoder inputs and encoder sequence inputs, and then we're going to have one output, which is nothing but decoder output. right? And then we have initialized the model, and then we'll just compile the model with the RMS prop and sparse categorical cross entropy loss function, and then the metrics will be accuracy, and then we'll train the model. We'll train the model on training data set. Number of epochs will be one epoch. We'll just have one epoch, and then we're going to validate the model on validation data set. So check how the model is performing, and then this is the code. We can actually get this output and like pre-process. So the outputs are going to be, of course, like positions, and then we're going to have to convert them into words. What are the corresponding words? This is what we do in this function. So here we could actually run it. So I have actually created a function in which we'll just like we will have training sentences, right? So over these training sentences, we are going to randomly pick a sentence, and then we are going to translate it. So we're going to have a bunch of training sentences. Let's just run it, and then let's use Google Translate to validate how good is this. So the input sentence is your house is 3 times as large as mine. And remember, these sentences, the model has not seen these sentences before. So these sentences are not from the training data set. These are actually from the testing sentences. So you can be sure that the model is actually performing pretty good. So I'll just open Google Translate. So to see if our translation is equal to or is same as the Google translation. So I'll just say English to Hindi, English to Spanish, English to Spanish. So I'll just put in this. So it is tu case. I don't want to pronounce that. Oh yeah, I mean yeah. Is it equal? Is it same? I think maybe somewhat same. I'll just put that sentence here to see what that means. So I'll just put this sentence. Right, we can't actually. Let's put this sentence. I'll put this sentence here. Let's to see what is the equivalent English translation. Right. So let's put here. Let's hope for something good. Yeah, I mean almost, as you can see here, the translation is your house is 3 times what is so. I mean, yeah, like the words are not actually in the right order, but still you could catch the meaning. So yeah, I mean you could catch the some of the meaning, right? And let's run it again. Let's do this. She is all skin and bone. Okay. I don't want to body shame here on YouTube, but okay, let's see. I mean, yeah, not that good, right? Not that good. But still, remember, we don't have NVIDIA RTX 4090. I mean, I can't afford that, but I mean, like we are training on, like we are only training for one epoch, which is like we are only updating the weights for like 30 steps maybe. So or we are only updating the weights for like very less number of steps, right? So therefore, the model is also not that complicated. We only have one encoder layer, one decoder layer, which actually surprises me. Like the results are pretty good. The model is able to get like very good predictions. Like at least get the meaning out, maybe like little contextual meaning, like very little. I'm telling you. Let's put that here. Let's hope. I can see the word 4 hours here, probably corresponding to hours. I mean, let's try this one last time. He's been in the 2 hours. Okay. And it is pretty good, not bad, not bad. The model is doing pretty good. So therefore, cheer up. You could build powerful language models for yourself, and maybe if you are lucky, maybe you can get a job or something. So yeah, I mean, we have done this. We have done this. We have trained a model, a very little model. Like think about it. If you have like if we have like NVIDIA 40X or like one of the powerful GPUs, maybe we can build the next chat GPT maybe. I mean, yeah, that is the goodness of here. You can just like this is not like a very huge code. We just train the very powerful model in just like very small number of lines of code. So like this is the best time to get into machine learning. So like thanks for watching, and I'll provide the code in the description. Download it from GitHub. Make some changes. Maybe if you have a powerful computer, maybe if you are rich, then you could increase the number of encoders, number of decoders, number of epochs. Maybe add some more complexity to the model, and if you have some good results, if you are like you can just put it in the comments or something. Like thank you for watching, and I'll see you in the next video.